Hello everyone, today we're going to be talking about properties of rational exponents. So first I'm just going to do a review over all of our exponent rules that we learned in Algebra 1. The first one is product of powers, and that definition is that if a to the m times a to the n, that's going to be equal to a to the m plus n. So when I am multiplying two things that have the same base, then I just add the exponent. And so if you recall, just for a little bit of vocabulary there, if I have a to the m, my a here is called my base, and m is my exponent. And so when I have this product of powers, I can only add the exponents when that base is the same. So for instance, if I have 5 to the 1/2 times 5 to the 3/2, those have the same base. So that means I can combine these by adding the exponents. So this would be equal to 5 to the 1/2 plus 3/2, which is equal to 5 to the 4/2, which if I reduce that fraction is equal to 5 squared, which is equal to 25. Next I have power of a power. So this is when I have a to the m parentheses all raised to the n power. Then what I do here is I multiply my exponents. So this will be equal to a to the m times n. And so that's when you have those two exponents that are basically next to each other, but just separated by parentheses. So here, 3 to the 5/2 raised to the second power would be equal to 3 to the 5/2 times 2, which when I multiply those fractions, I get 3 to the 5th. And 3 to the 5th power is equal to 243. I can also have power of a product, so that's when I have a times b all raised to the n power. And what I do here is when I have two things multiplied together in the parentheses and I'm raising it to the same power, I can distribute that power of n to both of those bases. So for instance, here I have 16 times 9 raised to the 1/2 power. This would be the same thing as 16 to the 1/2 power times 9 to the 1/2 power. Well, 16 to the 1/2 power is just equal to 4, because the same thing as taking the square root of 4. 9 to the 1/2 power is 3, and then 4 times 3, I get 12. Negative exponent, what I do is I flip it. So here I have a to the negative m. To make that positive, I move it to the denominator to become 1 over a to the m. So for example, I have 36 to the negative 1/2 power. To make that power positive, I would just write 1 over 36 to the 1/2 power. And 36 to the 1/2 power is the same thing as square root of 36, which gets me 6. A zero exponent rule is that anything raised to the 0 power is just equal to 1, except when a is 0. So here, 119 raised to the 0 power is just equal to 1. Then I have quotient of powers, and that rule is if I have a to the m divided by a to the n, so again here I have same base, this would be equal to a to the m minus n. So it's kind of opposite of what we saw with product of powers, that first one. When I multiplied two things with the same base, I added the exponents. So when I divide two things with the same base, I subtract the exponents. So here I have 4 to the 5/2 divided by 4 to the 1/2. Here I have the same base of 4. So this would be equal to 4 to the 5/2 minus 1/2. 5/2 minus 1/2 is 4/2, which is the same thing as 2. And 4 squared, I get 16. And then I have power of a quotient, and this again is really similar to power of product, where I just distribute my exponent. So I distribute my m to both the a and the b. So this will become a to the m over b to the m. So here I have 27 over 64 raised to the 1/3 power. This would be the same thing as distributing that 1/3. So I have 27 to the 1/3 power over 64 to the 1/3 power. So the cubed root of 27, I get 3. and the cubed root of 64, I get